Well, this is the end. I think the Romans finally got us.
Yup, they'll be here any minute to take us as prisoners. See, but I don't want to get capturado.
Come on, guys, it can't be that bad.
Oh, I think I'm gonna faint.
So what should we do?
I got it. We can all kill each other so they can't take us as prisoners.
Wait, what the heck? I want to live.
So I was thinking we could just sit in a circle and
Oh, what should I do?
off until there's...
For Josephus, there were 41 soldiers, but we've simplified the diagram to 12 people. Now, the way that they'd kill each other is they'd start with one random person, and that person would kill the fellow soldier to their left. Then, the next soldier would kill the person to his left, and the next to his left, and so on. This happens until one full cycle around is completed. What happens after that? Well, they start a new cycle. Going clockwise, each one would kill the closest living soldier to his left. These cycles keep repeating until eventually one person is left alive. This last person is the winner, and Josephus is trying to be that winner so he doesn't have to get killed and is instead captured by the Romans. So we can derive a pretty interesting mathematical problem from this scenario. For n soldiers, where should Josephus place himself so that he is the survivor?
Here's an example if n was equal to 4, or there were 4 soldiers in the circle. And here's an example when n equals 8.
Okay, now that we fully understand how this problem works and we've seen animations and examples of how this actually works in the circle, let's begin to try to find a solution to this problem. The first thing we should do is create a data table with points where x is the number of people in the circle and y is the number of the person who actually survives at the end. And using these variables, we can create a table. For example, when there's one person in the circle, the first person obviously wins because there's only one person, no one to kill. When there's 2 people in the circle, the value of y is 1 because the first person kills the second person, so therefore the first person survives. We've seen examples of 4 and 8, and using the same process, we can continue to collect data points for every number from 1 to 16. After creating a table that showed all the values of y when x was between 1 and 16, I began to see that there was a clear pattern. First off, I noticed that scattered throughout the y's, you could see that there were 1s in special cases. Specifically, when x was 1, y was 1. When x was 2, y was 1. When x was 4, y was 1. When x was 8, y was 1, and when x was 16, y was 1. When I analyzed these numbers, I found that they were all powers of 2. Using this information, I decided to make a new variable, z, and I defined it as the remainder after subtracting the closest power of 2 from the total amount of people in the circle. And I created another data table with 16 values of z for the 16 values of x. Upon analyzing this table, I once again saw that all powers of 2 had a 0 for the z spot. And then when I compared the values of z and y, I found that there was a clear pattern. Any value of y is equal to 2z plus 1. And the great thing about z is that z can be found for any value of x without knowing y. You can at any time subtract the closest power of 2 from the x value or the total amount of people in the circle and find z. This means that using this easy information, we can then plug this into the formula where 2z plus 1 is equal to y and find which position you need to be in order to survive. This is the solution.
Another method to find the answer when every second person dies is to use a method called bit shifting, which is the process of converting a base 10 to a base 2 number and using the digits of the base 2 representation and manipulating them to find the answer and converting that to base 10. That would be the answer. So first, pause the video and see if you can figure out what this number is in base 10. Okay, this number is 41, as you can tell, because each base 2 digit represents a 2 to the power of n value starting from the rightmost, which is 2 to the power of 0, all the way down to, in this case, which is 2 to the power of 5. So you add up the ones, like the 1 represents 32, 8, and 1, and which is 41. So therefore, it must be 41. So to bit shift, you just have to shift each digit one space to the left, where the leftmost digit becomes the rightmost, and everything else gets shifted to the left. Then you convert that into base 10, and that'll be your answer. Let's look at an animation for how to do it. As you can tell, the answer is 19, because 16 and 2 and 1 now have 1s. And yes, 19 works, and you can check the theorem. Now, if you want to know how to solve it for any case of n number of people who die, you have to use a computer, and the algorithm you would use is called recursion. As shown in the image, it's basically just like a block and a block and a block and a block. So a function just keeps on calling until there's one person left. So you would just create a function that calculates the person that dies in the sequence of moves. Then you output the position of the person. Then you recall the function with that position. And you keep on doing that until there's one person left. And that one person is your answer. Now for proving the theorem that 2l plus 1 is equal to the answer, where L is the 2 to the power of n value, which is closest to the number of people, you use induction, which is when you first put the base case when n is equal to 1, we obviously know the last person standing is number 1, and plugging it into L, it does equal to 1. And then you just use the hypothesis that assumes that for any k value, 2k plus 1 does give the last person standing. And then you would just use properties for proving that k plus 1 will work if k works. So that's basically how you prove the theorem.
Yay, I survived!